I am Dr. Ashish Vikhar, and in today's lecture we will learn about how to determine tensions inside the flat belt drive. As you can see here, the formula to calculate the tensions in a flat belt drive is T1 upon T2 is equal to e raised to mu theta. Now let us understand what are these terms. In this formula you will see that T1 is called as a tension in the tight side of the belt and T2 is the tension in the slack side of the belt. In the last lecture we have seen what is meant by tight side and what is meant by slack side of the belt. This is a driven pulley in front of you, that is drawn. This is a picture of the driven pulley, and in this picture you will see that a belt is there. This is the belt. This is a belt mounted on this driven pulley, and in that way we can see that there is a slack side at the upper one and there is a tight side at the lower side. So at the lower part of the belt there is a tight side, and at the upper part you will see there is a slack side. So here this slack side is nothing but having a tension T2, and the tight side is having somewhat more tension T plus delta T, that is also called as a T1. So T1 is the tight side tension and T2 is the slack side tension. After that we want to understand here what is the meaning of theta. As we know what is theta, theta is nothing but this angle which is called as angle of lap or angle of contact. You will see that this belt is in contact with the pulley from in the region A to B. If I draw the tangent, if I draw one line from A to O, which is nothing but the center point of the pulley, and B to O, you will get the angle subtended of the belt, and this angle is called as an angle of contact or angle of lap. So here we see what is meant by theta, and after that the mu is there. That is represented here. Mu is nothing but called as coefficient of friction, which is called as a coefficient of friction, mu. And this is the formula in engineering mechanics. We have seen coefficient of friction, and in this that term is going to be utilized because F is nothing but the frictional force, and because of the frictional force or frictional grip between the belt and the pulley we get a frictional power, and because of that the belt is going to rotate. So F is equal to mu into R. R is nothing but normal reaction. So here by using all these terms, one is called T1, another one is called T2, after that mu and theta, we are having this relation T1 upon T2 is equal to e raised to mu theta, and this is a formula of ratio of driving tensions. T1 upon T2, ratio of driving tensions. T1, one tension is tension in the tight side and another tension is tension in the slack side. So T1 upon T2 is equal to e raised to mu theta, and this is the formula, mathematical formula, particularly in case of flat belt drive. Thank you very much.